For page 15 of the scheduling notes, we're going to use the scheduling template from the Learn site. So I'm going to Lectures, Lecture Handouts, and I'm going to download the scheduling template. So this is page 15, and I'm just going to fill in the scheduling parameters here. So 18 and 8, 30 and 10, 45 and 10. The method here is EDF, that's earliest deadline first, and we're doing non-preemptive, the non-preemptive version. So our schedule length, or the LCM of the periods, is equal to 90. There's 20 boxes here, so I'm just going to use every 2 boxes to represent 10 time units, so every box is 5. So I'll just label them at the 10s. And I recommend you do the same. So this is scheduling graphically, and hopefully it will help you to understand how the scheduler works. You wouldn't do, if you're building a tool to do this, you'd figure out some kind of algorithm. Okay, so next thing to do is to mark on here their deadlines. Remember the deadline is assumed to be equal to the period, and so task 1, task 2, and task 3, they're all released at time 0. That's the assumption. They're all ready to run. And then task 1 is going to be released every 18 time units. So at time 18, at time 36, this is approximate here, but I'll label it underneath 18, 36, 54, and there's a scheduling problem in the homework, and there will probably be one on the second quarter test, so I recommend you always start by just filling in the deadlines. The next deadline for task 1 is at time 72, and then the last deadline is at time 90, and we'll stop there. So task 2 has a period of 30, so it will be released at time 0, at time 30, at time 60, and again at time 90, but we won't, I guess I can write that, 90, whoops. And then task 3 is released every 45 time units. So here we are. So time 0, time 45, and time 90. So now what we do is we start at time 0 and we look at which task has the earliest deadline. And we can see that visually task 1 has the earliest deadline, is due by time 18. So we're going to schedule it first, and it takes 8 time units. So I'm going to represent that by shading in 8. And so task 1 finishes execution after 8 time units. This is a worst case analysis. And it cannot run again. It's not going to be released again until time 18. So now we have to pick between task 2 and task 3. Task 2 now has the earliest deadline, and so it will start at time 8, and it has worst case execution time of 10, and so it will finish at time 18. Now at time 18, task 1 has been released again, so it's ready to run, and task 3 has been released and it's ready to run. Of those two, task 1 has the earlier deadline at time 36, so it will run again, and it will take 8 time units, so that will take us from time 18 to time 26. At time 26, the only task that's ready to run is task 3, so it finally gets its chance, and it's going to run for 10 time units, so from 26 to 36. Okay, now at time 36, you can see that task 1 is ready to run again, it's released. Task 2 was released at time 30, task 3 is not re-released yet, so we've got to choose between task 1 and task 2. Task 1 has the closer deadline of 54, so we are going to schedule it, and it's going to run for 8 time units to time 44. At time 44, task 3 has still not been released yet, so our only option is task 2, which is waiting to run, takes 10 time units, so it goes to time 54. Now at time 54, task 1 is released again, task 3 is waiting to run, so we choose between those two. The closest deadline is at time 72, so we're going to choose task 1 to run from time 54 to time 62. And at time 62, task 3 is still waiting. Task 2 was just released at time 60. So at this point, there's a tie. The deadlines are tied for task 2 and task 3. They both have a deadline of 90. So there is a tie at t equals 62, and the tie is that the deadline, so absolute deadlines are shown with a lowercase letter, relative deadlines with uppercase. So the absolute deadline for this instance of task 2 is 90, as is the absolute deadline for task 3. And so how do you solve this? You just pick one. Arbitrary choice, it doesn't matter. One's not better than the other. And so you can do this however you want. I think that just to prove a point, I'll choose task 3 at this point. It's going to run for 10 time units to time 72. And look what happens at time 72. Both task 1 and task 2 are ready, and they both have a deadline at 90, so we have another tie. So there is a tie at t equals 72, and that tie is that absolute deadline of task 1 is 90, absolute deadline of task 2 is 90, and again, just pick one. I'm going to pick task 1 this time. So that's going to run from time 72 to 80. And at time 80, there's only one task that's been released and hasn't run yet, and that's task 2. So we had to make a choice at time 62, and we had a choice of 2. We had to make another choice at time 72, and we had a choice of 2. So there are 4 different permutations of the schedule, and they're all optimal, they're all equally good.